All right, folks, let's take a look at this. Given A, 2, 4, B, 2, 10, and C, 6, 10, find the circumcenter of triangle ABC using algebra. All right, so here's ABC. I've graphed it, connected the lines. First thing, the equation of the perpendicular bisector of AB. All right, no problem. Can you see that AB is a vertical line? If it's a vertical line, this is going to be quite easy to handle. All you do is say, okay, B is at 2, x equals 2, and C is at x equals 6, 2, 6. So what's halfway between 2 and 6? 4. So come right here to 4 and drop a perpendicular. All right, so there is your perpendicular bisector of BC. Now, what's its equation? Well, see BC right here? Every vertical line takes the form x equals k, so this will be x equals 4. That was easy, wasn't it? All right, let's look at AB. AB. AB goes from y equals 10 down to y equals 4. So what's halfway between 4 and 10? Well, how would you do that? 4 plus 10 is 14, divided by 2 is 7, okay? So right here, let's draw that in. All right, so we got that. Now every horizontal line takes the form y equals k, so this will be y equals 7. All right, now just looking at it, we can see that the circumcenter of ABC is going to be the intersection of this perpendicular bisector and this perpendicular bisector, and they intersect right here. Okay, they intersect right there. Well, that looks like it's the order pair 4, 7. So we're going to say the perpendicular bisector is at 4, 7. But we're not supposed to do this graphically. We're supposed to do it algebraically. So how do we do that? Well, we solve this system. Do you see it's a system of equations? Y equals 7, x equals 4. That's a system. But clearly x equals 4 and y equals 7. In other words, the system is already solved. There we go. Points in the bank. All right, next problem here. This will not be as easy. You'll see that whereas part B will be easy, part A and C will be more work now. Hence I say show your work. All right, let's graph this thing. A is at -1, 6. B is at 1, 10. And C is at 1, 2. All right, now we need to, -1, 6 is actually right here. 1, 2, and 1, 10. Perfect. Let's connect those dots. All right. That was A, B, C. Now, why is side BC going to be easy again? Because BC is a vertical line. Therefore, its perpendicular bisector, easy to find. You have y equals 2, y equals 10. What's halfway from 2 to 10? If you're unsure, you can add 2 plus 10, which is 12, divided by 2, which is 6. So y equals 6 right here. Great. Let's just see if we can't get that done. All right. Now it's a horizontal line. Every horizontal line takes the form y equals k. So what is it? It's y equals 6. All right. Next, we want to get the perpendicular bisector of AB. Well, that's not easy. It's not horizontal. It's not vertical. So you're going to have to go through 5 steps to get just through part A, right? A lot more work than you'd think. Let's start. The first step is you're going to have to get the capital M, midpoint of AB. The midpoint of AB, you have to know the formula, is going to be x1 plus x2 over 2, y1 plus y2 over 2. x1 plus x2 over 2, y1 plus y2 over 2. All right. So that's going to be negative 1 plus 1 is 0. 0 divided by 2 is 0. 6 plus 10 is 16 divided by 2 is 8. We can even check to see if this midpoint makes any sense. 0, 8 is right here. Does that look like the midpoint of AB? Sure does. All right, now we get the slope of AB. Slope is lowercase m. And the formula is going to be y2 minus y1 over x2 minus x1. Okay, y2 is 10. y1 is 6. x2 is 1. x1 is negative 1. y2 minus y1 over x2 minus x1. Well, I guess it gets you 4 over 2, which equals 2. All right, so what do I have? I have the midpoint of AB. I got the slope of AB, which is 2. That makes sense. It means rise 2, run 1, like rise 2, run 1, rise 2, run 1. That works. But I really want the slope of the perpendicular bisector of AB. So I need to get the slope of the perpendicular bisector of AB, which is going to be the negative reciprocal of this slope. So you get negative 1/2. All right. Let's just graph this, okay? Negative 1/2 means down 1 over 2, down 1 over 2, down 1 over 2, like that. So I could graph this line very precisely, actually. Now, I need the equation of this line, Well, let's see. I have to do, oh yes, write the equation of this line in slope-intercept form. And I have to know that's y minus y1 equals m times x minus x1. So y minus y1 is equal to m times x minus x1. That's in point slope form. I need to convert to slope-intercept. Negative 1/2 times x minus 0 is negative 1/2 x. Bring the 8 to the other side. Y is equal to negative 1/2 x plus 8. There we go. That is an equation in slope-intercept form. Does that make sense? It's got a y-intercept of 8. That seems right. Slope of negative 1/2, down 1 over 2, down 1 over 2. Looks like I got a good line there. All right. That took work. Let's review the 5 steps. Step 1, find the midpoint of AB. Step 2, find the slope of AB. Step 3, find the slope of the perpendicular bisector of AB. Step 4, find the equation of the perpendicular bisector of AB in point slope form. Step 5, find the equation of the perpendicular bisector of AB in slope-intercept form. All that for part A. All right? All that for part A. Well, let's skip to part C. We know we need to get we need to get the the circumcenter. The circumcenter is going to be intersection of these two perpendicular bisectors, right? Take this perpendicular bisector and this perpendicular bisector. They intersect right here, it looks like. I'll darken that up. What does that appear to be? That appears to be 4, 6, doesn't it? So it looks like the circumcenter should be 4, 6. But we don't get to cheat and use that graphical attack. Instead, we have to use the algebra. So it means we have to solve a system of equations. Great. What are my 2 equations? Well, one of my equations is y is equal to negative 1/2 x plus 8. That was my perpendicular bisector of AB. My other equation is y equals 6. That's the perpendicular bisector of BC. Now I solve. You can solve the system by substitution or elimination. The easiest thing to do is substitution. Y equals y, therefore, negative 1/2 x plus 8 equals 6. See that? All right, bring the 8 to the other side. You get negative 1/2 x is equal to negative 2. All right. Divide both sides by negative 1/2, so you get x is equal to 4. Now that's half of this 4 comma 6, but you already have the other half right here. Do you see it? Y equals 6, 4 comma 6, x comma y, 4 comma 6. Done. All right. All the problems in this set are very similar to this, okay? Last thing I'm going to do is just show you how to do the construction in case you forgot. So, problem 3 is going to be easy, like problem 1. Problem 4 is going to be a little harder, like problem 2. And then problem 5 and 6 are circumcenter problems with constructions. Now, you probably remember this construction here. Just grab my compass real quick. All right. How did we do this? Well, we put the pointy side on A. Let's look at AB. We open up so we're more than halfway from A to B. And we make ourselves a half circle arc. Then we put the pointy side on B. We make the same half circle arc. These 2 points, darken them up. Use your straight edge. Make this line. BC. Go from B more than halfway to C. I went like 3/4 of the way here. Make an arc. Put the pointy side on C. Make the same arc. Darken in the 2 points of intersection. Get your straight edge. Make the perpendicular bisector. So your perpendicular bisector of AB, perpendicular bisector of BC, and they intersect right here at what's called the circumcenter. Now, what if I say then draw the circle that circumscribes ABC? Well, what do? You put the pointy side on the circumcenter, and you put the pencil side on any of the 3 vertices of the triangle. So I just go ahead and put it on B. Swipe out a giant circle, and I'll notice that, well, if I had done it very precisely, A, B, and C all land on the circle, and the triangle's in the interior. All right, why don't we do one more down here, fresh. Okay, I'll go AB. I'm going more than halfway. Make my half circle arc. Oops. Pointy side on B. Half circle arc. Oops. All right. Important point there, important point there. Now my straight edge. Go ahead and make an intersection. That's my first perpendicular bisector. Now we'll go BC. More than halfway from B to C. Half circle arc. More than halfway from BC. Same length. Half circle arc. Whoops. These 2 points are very important. The intersection points. I drive a line through these 2 points. All right. And what do I notice? I notice these 2, that's a perpendicular bisector. These 2 perpendicular bisectors intersect right here. Yeah? So that thing right there, this right here, is the circumcenter. All right, so saying I did this right, I should be able to put the point D side on the circumcenter and the pencil side on any of the 3 vertices. I'll put it on C this time. And I should be able to just draw a circle that'll intersect all 3 vertices. Oof, this is bad. I did not do a good job on this one. You can see that, right? I'm missing A and B pretty dramatically. So I'm going to go ahead and just see where I might have gone off.
Extension 100, Gary Moore. Please call extension 100.
This looks good. This looks good. Okay, so that doesn't seem to be a problem. It's probably on this one right here. We'll go from A. Okay, so that's that arc. All right, so then this guy over here, put him on B. That looks pretty good. Well, should be working. Let's try this again. I'm gonna put the pointy side. Let me see if I can be more precise about where their intersection is. It looks like it's right about here. Maybe that'll help. Okay, I'm gonna go to A this time and try it one more time. All right, I hit A and B really well that time. Not pretty close to C that time. All right, this I can take. All right, so we got a nice strong hit on B, a nice strong hit on A. Came pretty close on C, but I missed it by just a little bit. All right, it's just the imprecision of using a tool like this. This one's looks slightly bent, and therein lies the problem. All right. Hope that's helpful.